Hello guys, welcome back to my channel, and in today's lecture we will talk about the characterization of the signals. Characterization is basically defined as the properties on which, depending on that, we generally classify our signals, that if this particular group of signal is following such kind of properties, then that will be come under the some other classification, right? There are different characteristics of the signals. So depending on the properties, depending on the characteristics, we classify the signals in different domains. So the very first domain is the even and odd signal, right? So we will talk about even and odd signal in detail. Basically, even there are some set of rules. If the signal satisfies those rules, then the signal is known as even signal, and similarly for the odd signals, right? Second categorization is periodic and aperiodic signal. So periodic signal is also a set of rules. That means it is the characteristics of the signal, the behavior of the signal. Depending on that, we generally say that the signal is periodic or non-periodic, and that characteristic is that if the signal is repeating itself after a such particular time interval, then we say that it's a periodic signal, and if it does not repeat itself in a such manner, then that is known as a aperiodic signal, right? In the same way, we classify the signals in set of energy and power signals, right? So energy signals, we have some rule, that's the, and depending on those rules, we have a two type of cases. If the energy is something, power is something, then we will say that that signal would be energy signal, and similarly set of rules for the power signal. We will do all in the detail in the coming lectures, right? And next is the random and deterministic signals, right? So random is itself, that is not deterministic, or we can say that that signal whose characteristics are not secure, whose characteristics are not permanent, that is changing with time. For every instant of time, that may change, that may not change. That's depending on the nature of the signal, right? So, second thing is the deterministic signal. Deterministic signals are those signals, by seeing the properties we can say that, yeah, this is the value, or we can say that something kind of certainty is always present in the deterministic signal. One example for random signal would be the noise signal. In the communication, the noise is classified as the random signals, right? And last but not the least classification or characteristic is the continuous and non-continuous, or we can say that continuous and discrete signals, right? So continuous signals are those signals which are defined for each value of the time, right? So those signals would come under this category, and the discrete signals, those are defined in particular time interval, then other time interval of the signal varies with another property, then third interval and fourth, and like that. So those signals comes under the discrete signal, right? So let us begin with very first topic, that is even and odd signal. So when the signal would be called as an even signal, or when the signal would be called as an odd signal, that is depending on these particular criterias. If we have a signal x of t, if we have an arbitrary signal x of t, in that case, if that signal satisfies this rule as x of minus t is equal to x of t, then we say that the signal would be even signal, right? What it is written over here, basically we can see this, that if arbitrary signals time reversal is equal to the same arbitrary signal, then we say that the signal is an even signal, right? So we have some examples over here. So examples includes cos signal, sinc signal, and also we have learned in the previous lecture, that is delta t signal. So the examples for the even signal are cos, impulse, and the sinc function, right? So let us start one by one to see that what are the properties and how the process in which we can see that these signals are even signals, or we can say that these signals comes under the even signals category, right? So let us begin with very first, that is the cos signal, right? So if we talk about cos signal, cos has a property like cos of minus theta is equal to cos of theta, right? So this is also one way to prove that cos theta is an even signal, because we have a property for even signal is x of minus t should be equal to x of t, correct? So in that case, you can see directly over here also, we have one more process, that is the graphical manner in which we can see that cos signal is even signal, right? So let us start with that. If you draw the cos signal, how you will draw the cos signal, right? So the cos is having always value as +1 for time t is equal to 0 and follows the pattern like this, right? This is -1, this is t if it is cos of t, right? So if you take the mirror image of this signal, what does it mean by mirror image? Because we have to find out x of minus t, that is time reversal, right? If we talk about the time reversal, that means take mirror image about y-axis, right? So if we talk about the mirror image about the y-axis, then how you will do this? This is simply, you have to put a mirror over here and see from both the sides and draw the signal, right? So if we try to draw x of minus t, or we can say that cos of minus t, what you will see, if we place a mirror over here, if you see from here, that means this part will map on this side and this part will map on this side, right? So if talk about this part, so this will map like this and this part will map to this part, right? In other way, we can say that the left part will map with the left part will map towards right side and right part of a signal would map on left side. So you can directly see over here that both are the same things. That's why we say that it's following the properties of even signal. That's why cos is an even signal. Right? Similarly, if we talk about impulse signal, right? Impulse is delta t, and if we can draw the impulse signal, how you will proceed? So nothing is different. In the same way, we will draw delta of minus t and compare that. If delta t is equal to delta of minus t, in that case we will say that it's an even signal, right? So just begin with drawing. So delta t is defined as 1 for t is equal to 0. It's 0 for t is not equal to 0. That means at this point t is equal to 0, we will get the value as 1 and this is the delta t, right? If you talk about the mirror image, or we can say that if we want to draw the time reversal, then you will place a mirror over here and you will find nothing on the both the sides, because this is also 0, this one is also 0, right? So what we will get? Only the value at the x-axis, only the value at the y-axis. So if we talk about delta of minus t, how you will plot it? Delta of minus t would be like this only. So delta t is equal to delta of minus t, right? That's why we say that it's an even signal, right? Next is sinc function, right? So how the sinc is defined? First of all, we should know about what is the sinc function. So in a very simple manner, sinc is defined as sine of pi t divided by pi t, right? And when you will draw this, you will plot this signal, you will find that this will be drawn like this, right? This is something like dump nature, right? That is envelope is like a dump signal, and in between that we have a cosine signal. So if you draw its time reverse signal, that means if we want to draw x of minus t, right? So this right part would map into the left part, and this left part would map into the right part, right? So if we map this part, that is like this, and similarly for second part. So both the signals are same. That's why we say that sinc function comes under the even function, right? Next is the odd signal. In the next part, if we talk about the odd signals, that means those signals which have a property like x of minus t is equal to x of t, those comes under the category of odd signals, right? So examples include sine function, square function, signum function, right? So what would be the process to identify this? That is the same. If we have been given with a signal x of t, we have to take the time reversal and we have to draw minus x of t. If both the signals are same, then we say that it's an odd signal, right? So odd is having a minus sign over here. That's why we say that it's an odd signal, right? So we have examples. Example includes the sine function, right? So very first we will see that how the sine function is a odd signal, right? So if we talk about the sine, we can draw the sine function like this. That means if we draw sine of t over here, right? So sine is having always value at 0 as always 0, right? And at pi by 2 we have value 1, then 0, right? So if we talk about drawing the signal or graphical representation, that graphical representation would be like this, right? This value would be plus 1, this would be minus 1, right? So if we talk about sine of minus t, right? So how you will draw the sine of minus t? Nothing is special. It's similarly like we will draw the mirror image of both the sides, right? So if we talk about the mirror image of this signal, then this will plot over here like this. Similarly, this part would be like this, right? So the thing which was at plus 1 is now appearing at minus 1, right? So whatever be at the plus graph, that is having the value as plus 1, and at the blue part we have that same as at minus 1, right? So plus magnitude shifted to the minus 1. That's why it comes under this category, right? Similarly, if we talk about the square wave, so how you will say that square comes under this category? So let us draw with a very initial step as x of t. Suppose this is a square signal, right? If we talk about a square signal, it is drawn like this, right? Now if you will take these steps, you will definitely identify that this is the odd signal. If you have any problem, you can ask to me in the comment box. And third is the signum t, right? How the signum t is defined? Very first we should know about the definition of the signal, right? So if we talk about signum of t, so the signum of t is given as plus 1 when t is greater than 0, and its value is minus 1 when t is less than 0, right? So if we represent this signal graphically, then how you will show this signal? If we are drawing signum t, then you will say over here for t greater than 0. That means this right side part, and if t less than 0, that is less, right? That is left hand side part. So this is plus 1, this is minus 1. So you can draw the signal like this, right? So this is about the signum t, right? Now, if you can draw the signum of minus t and that is equal to minus of the signum t, then you can say that this signal comes under the category of odd signal, right? So, if we take the mirror image over here, then what will happen? So, whatever is in the right hand side, that will map to the left hand side, and whatever is on the left hand side, that will comes under the right hand side, right? So, green graph is signum of minus t, right? Now you can clearly see over here that the plus amplitude has been traced over the minus value, right? So we can say that this is also comes under the category of odd signals, right? Now we have some combinations and direct observations. Depending on that, we can find out what would be the end result if we have been given with the combination of even and odd signals, right? Those combinations are given in the multiplication form and in the algebraic sum forms, right? So let's list out all those combinations so that in the case of examination, if the question appears, you can easily identify that the which combination will give the which results, right? So if we have been given with a even signal, right, and we have been given with the odd signal, right, then in that case, if the multiplication is asked and it is asked to find out what would be the multiplication of these two signals, whether it would be an even signal or it would be an odd signal, then in that case you will say that how you will identify it, because odd is having negative sign. It's not a concept, it's just a analogy which we can create in our mind, that whenever we talk about the odd signal, the odd is always having negative sign over there, right? That's why I had placed a negative sign over. If you multiply plus and minus, you will always get minus. That's why this would always be an odd signal. Similarly, if we have an even signal multiplied with even signal, right? So if plus is multiplied with plus, you will always get an plus, that is even signal. If you talk about two odd signals, right? So minus multiplied by minus will become plus, that's why this would become even signal, correct? Next is, if we have been given with even signal and we have been given with odd signal, right? So odd is minus, this is plus, right? So whenever the combination is present like this, that means this will depend always at the magnitude of the odd signal. If the magnitude of odd is greater than even, then this will become negative, and if even signal is greater than odd, then this will become positive. So in such criteria, we say that it's neither even nor odd, right? Next is, if we have been given with even plus even signal, then this is always as even signal, right? And if we have been given with odd plus odd combination, that means minus minus will always give odd function, right? So this is all about the combinations of even and odd signals. So by using these observation, we can directly find out our correct option, right? One more thing is here with even and odd signal, that in general we are asked with find if our arbitrary signal x of t is given us and it is asked about find out the value of even part of xt and odd part of xt, right? So there is a simple set of rule. If we talk about x even part of t, that is given as x of t plus x of minus t divided by 2. So if you will draw this combination, you will get x even part of t. And similarly, if we talk about odd part, this would become x of t minus x of minus t divided by 2, right? So these are the important things. which I think that it should be covered in the lecture. This is all about the even and odd signals. In the next lecture, we will talk about periodic and aperiodic signals, right? So thank you for watching my channel. So you all are welcome to come up on the channel and please see the lectures. Thank you. Please subscribe, like and comment on the channel as well. Thank you for giving your time.